Hey, what's up? I get asked about this problem all the time. Let's dive right in. Great example of an exponents question with addition and subtraction in it. And there's really one key to the game when you see this kind of thing, which is when you're adding and subtracting exponents, just factor out a common term. If it's been a while since you've factored anything, let's just talk about factoring in general for a moment. 6 plus 9, perhaps obviously there's no reason to factor this during the exam. It's just an example to help you understand what I mean when I say factoring. And what you're doing when you're factoring stuff out of an addition or subtraction is you're thinking about a number that would divide this number and also divide this number. Perhaps obviously in the case of 6 and 9, that would be the number 3. So I'm going to divide both of these by 3, and what that's called commonly is like pulling a 3 or pulling that common factor out of each term in the addition. 6 divided by 3 is 2, and 9 divided by 3 is 3. You can always check your math by just redistributing the number that you originally factored out, and you'll notice that winds up being 6 plus 9 again. So we haven't changed the value of the expression, we've just changed the way that it looks. So why would we do that on an exponents question? Well, the cool thing about factoring is that you can take something that used to be addition and you can transmute it into something that is now multiplication. Probably not news to you that 2 plus 3 equals 5, but you'll notice that 6 plus 9 equals 15 and 3 times 5 equals 15. Now, in most math situations, this is just totally redundant. It's not actually useful to factor out common terms, but when you're on the exam and you're looking at exponents questions and you're adding and subtracting exponents, it's super, super helpful. Let me show you why. You'll notice that this problem is pretty close to having 2 to the x power in both of the exponents. This piece might be a little bit confusing for you, and if it is, you probably just need a little bit of basic work on exponents. I'm not going to dive deep on that right here, but I'll give you a broad overview so you can understand what's happening here. If I took x to the 5th and multiplied it by x to the 3rd, you'd probably be thinking, oh, I know a shortcut for that. I add the exponents, x to the 8th. Now, if you just started studying, you might be a little rusty on that, but if you've been studying for a while, that's probably pretty familiar. But you probably wouldn't have written it as x to the 5 plus 3 power. You probably wouldn't have really written that intermediate step. That would be unusual. But the reason I'm taking the time to put energy into that is it'll help you understand this kind of situation a little bit better. Because 2 to the x minus 2 is really just 2 to the x times 2 to the negative 2. And here's the interesting thing. If you're like most people, if you saw it this way, you probably wouldn't hesitate to rewrite it like that. It's probably pretty heavily conditioned already that you would do this kind of move. But a lot of people just wouldn't really think of going from here to here. It's just much less intuitive for whatever reason. And same thing here. A lot of people just don't think, oh, I'm going to undo this addition or subtraction in the exponent into multiplication. But it actually ends up being quite valuable here. And here's why. If I rewrite this as 2 to the x times 2 to the negative 2, it might make it a little bit easier to see that you've got 2 to the x power in both of these terms, just like we had 3 in both of these terms, 6 and 9. That should make it a little bit easier to see that you can factor out 2 to the x from both of these terms. So let's go ahead and do that. 2 to the x divided by 2 to the x is, of course, just 1. And then 2 to the x times 2 to the negative 2 divided by 2 to the x is just 2 to the negative 2. So we wind up with that. And I'll just leave the right side alone for the moment. Now, hopefully you're already starting to think at this point along the same lines that I was discussing up here, which is, okay, maybe I'll just add these two little things and it'll turn into multiplication for me, and hopefully I can trust Isaac that that's gonna really help me out. So let me show you why that is true. Let's compute 2 to the negative 2nd power. Again, if you're just starting out, this might be a little bit unfamiliar, but you'll want to memorize that negative exponents are just 1 over the positive version of the exponent. So for example, 1 over 2 squared is the same as 2 to the negative 2 power. And if you want a detailed explanation of how that works, there's plenty of awesome places out there you can learn that. For now, we'll just run with it. Hopefully you know that 2 squared is 4, so we're going to wind up in this parentheses situation with 1 minus 1/4. Let's go ahead and make some space for that. So 1 minus 1/4, and now we're here. Hopefully you're okay with me going from 1 minus 1/4 to 3/4. Definitely comment below if you're not sure how that happens. And then we've got quite an interesting situation going on here, because you'll notice now everything that used to be addition and subtraction has been transmuted into multiplication, and that's pretty much always good on exponents questions on the exam. Okay, so I'm going to do one of my favorite things, which is getting rid of denominators by just multiplying both sides by 4. But there's many, many different ways you could run the numbers here from this point forward, and it doesn't really matter how you do it as long as you're comfortable and you don't make a mistake. But I like getting rid of denominators. It tends to simplify things, and I'll wind up with 2 to the 13th times 4 over here. So I've got 2 to the x times 3, which is the 4 cancels here, and then this 4 is going to multiply in over here. So I got 2 to the x times 3 equals 3 times 2 to the 13th times 4. Now at this point, I'm going to do another one of my favorite things, which is canceling stuff out on both sides of the equation. And I'll do that by just dividing both sides by 3. So on the left, I'll have 2 to the x, and then over here, I'll have 2 to the 13th times 4. Now this might be a little bit annoying at this point, but it brings us to another really powerful principle on exponents questions, which is you want as many bases in the problem to be the same as you possibly can. You want to make as many bases the same as you possibly can on exponents questions. So if I have a base of 4 here and a base of 2, I would prefer that all of those be base of 4 or all of those be base of 2. Usually smaller is better, so I'm just going to turn this into 2 to the 13th times 2 to the 2nd equals 2 to the x. And at this point, if the light bulbs weren't going off previously, hopefully they're starting to go off, because if I multiply by the same base, what do I do with the exponents? I add them. So this is going to be 2 to the x equals 2 to the 15th. Now, if 2 to this thing is equal to 2 to this thing, which is what this equation is saying, then these things in the exponent, they just have to be equal. There's no other way that these two quantities can be equivalent if that's not true. And so here we know that x is 15. We're picking D, and we're one step closer to grad school. Feel free to comment if you have any questions on this stuff, and if you want to learn how to reach your dream GMAT score faster, just head to our website, thegmatstrategy.com, and we will be happy to hook it up. Talk soon.